Good day and hi Professor. So this is my solution to project 1C, and which we are required to rank text documents based on specific queries using TF, IDF and cosine similarity. So first of all, I started by importing necessary libraries such as PDF Plumber to handle PDF files, the NLTK library to handle stop word removals, form stemming and tokenization. And finally, I also use the sklearn library so that we can perform the TF-IDF vectorization and also to perform the cosine similarity calculation. So then I reused the file reading functions from project 1A, which reads text and PDF files, and then I also reused the pre-processing functions from project 1B. So in the main function here, we'll first and foremost input our directory path that contain the files. So it's we'll be using, in this case, we'll be using a folder which contains multiple files. And then the files will be stored as documents in a list, and then it'll be sorted so that the order is stable for the name. Finally, then we will perform the TF-IDF calculation by using the sklearn library just now. And then this program will save the matrix output to a .csv file. Okay, after that we'll enter in the queries. Then we will transform the query into vectors, and then we will show the vectors for the query terms, and then identify the relevant stem terms in the query. Then we will get the stem query tokens that are in the corpus vocabulary, so that this will give us the common dimensions or features that are needed to be shown in the output. Okay, so after that, I also included the similarity calculation using cosine similarity, and this one is already included in the sklearn library. So we'll just put that in, and then it'll print out. Okay, so now let's run this program. I'll press run Python file, and then I will copy this address, which links to the folder in my local storage. Enter. Alright, so now it has performed the calculation. I'll maximize the panel size. So first, document matrix will be saved into this .csv file, which I'll open shortly. So here's the processed query, and here's the vector of Q and the document vectors for relevant terms. Here's the similarity distance calculation and rank documents. Okay, so we can conclude that the main function works, and it is able to produce an output for the vector of Q and document vectors, and also similarity distance calculation using cosine similarity, and rank them. So for the next query, and as you can see, it works. It runs the first objective, which is to find vector Q and document vectors, and also the second objective, which is to find similarity distance calculation and by ranking documents itself. Okay, so now I'll open up the TF-IDF matrix output, our file. Whoops. So here it is in my IDE. I'll open up in Excel as well, so it's more clear on the formatting. Okay, so yeah, as you can see here, so on this column A, we have the PDF names, and then we'll also on this row 1 we have all the unique terms that occur in all of the files. So it spans across. Some has a value, some doesn't, and overall there's around very stretches very long. So all in all, this function works too, saves the TF-IDF weighting, and it also shows an output in the terminal here. However, it's just a snapshot of the TF-IDF weighting. So for the full weighting, it'll be saved in the .csv file. So that's it for my demonstration of my solution for project 1C. Thank you very much, Professor.